Hello children, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Now, today we are going to discuss about the theory of equations, right? Theory of equations, let us see some of the problems based on this. In our previous class, we have discussed about that if a cubic polynomial having three roots, if the three roots are in the form of arithmetic progression, and geometrical progression, harmonic progression, what is the condition will be there? We have discussed those concepts, right? Now, let us check some of the problems based on this. Yeah. Here, x power 4 is the highest degree. That means the degree of the polynomial is 4. This is biquadratic polynomial, and this polynomial is divided by x minus 4. Biquadratic polynomial is divided by x minus 4, then the quotient is. So, previously we discussed about the remainder theorem and factor theorem. If the same question is asked about that remainder, we can directly substitute 4 value in the place of x. Because if x minus 4 is a factor, or if x minus 4 is divides this entire biquadratic polynomial, when you substitute plus 4 in this polynomial, we will get the remainder. Or according to the factor theorem, this entire polynomial is divided by x minus 4. That means if x minus 4 is a factor of this polynomial, we can find f of 4 directly. F of 4 means that means if you take this polynomial as f of x, we need to find f of 4. That means in the place of x, we need to substitute 4. That means 4 will be the root or solution of the given biquadratic polynomial. Okay. So for finding the remainder and factor, we can directly substitute, but you're asking about the quotient. So that's why we need to, we have learned the concept of synthetic division. Okay. So let us apply the synthetic division to identify its coefficient. So what is the polynomial here? X power 4 minus 6x cube plus 3x square plus 26x minus 24. So before doing the synthetic division, let us check all the terms are available or not. That means x power 4, x cube, x square, x constant term. That means if the degree of a polynomial is 4, then the number of terms will be 5. So are there 5 terms are here? Yes, 1, 2, 3, 4, 5. Yes, all 5 terms are presenting here. Now we can take their coefficients. Okay. Now what is the coefficient of x power 4? Is 1. X cube coefficient is minus 6. X square coefficient is 3. And x coefficient is 26. And the constant term is minus 24. Let us apply the synthetic division. It is given that it is the divided by the linear polynomial x minus 4. Now I am using 4 here. First position is 0. Now 1 plus 0, addition we are doing here. 1 plus 0 is 1. Next 4 ones are 4. We should write here. We need to multiply these two. 4 ones are 4. And minus minus 6 plus 4 is becomes minus 2. Minus 4 into minus 2 is minus 8. Again, if you add, you will get minus 5 here. And 4 into minus 5 is minus 20. Plus 26 minus 20, opposite sign. You need to do subtraction here. 6. 4 6 are 24. That means plus 24 minus 24 becomes 0. This is the remainder. Okay, na? Then what is the coefficient? This is constant term. Here minus 5 represents x term. Here right side onwards constant x term, x square term, x cube term. You need to write it in order like this. So 1 into x cube minus 2x square minus 5x plus 6. So this will be the quotient if the entire biquadratic polynomial is divided by x minus 4. So our answer is option 4. This is our answer. Okay, na? Now let us go to the next question. The quotient and the remainder. Again, to find the quotient, again we need to use the synthetic division. Same format, but let us take the given polynomial degree. The given polynomial degree is 5. 5 means how many terms must be? 6 terms. So let us count. So 1, 2, 3, 4, 5, 6. Yes, absolutely we have the 6 terms. Let us take their coefficient. I am just writing the polynomial once again. This is 2x power 4. Okay. Minus 3x power 4. 2x power 5 minus 3x power 4. Plus 5x cube minus 3x square plus 7x minus 9. Okay. Now, what is this? This entire fifth degree polynomial is divided by quadratic polynomial. If it is linear polynomial, we will get only one. That means one time we will take. That means only one of the factor we are taking here. One of the root we are checking here. One of the solution we are checking here like this. Okay. Now here biquadratic. What is the biquadratic here? Sorry, quadratic formula. Quadratic polynomial. X square minus x minus 3. Okay. Now first of all, let us write the coefficient of the f of x. 2 minus 3 5 minus 3 7 minus 9. Okay, na? Positive symbols no need to write. Now while I am taking that quadratic polynomial, x square coefficient is how much? X square coefficient is minus 1. So I need to take plus 1. And the constant term is minus 3. I should take plus 3. Now here first two places are zeros. Here 0 and last. That means in this second row, first row I have taken the coefficients. So in this second row, first position and last position will be zeros. And the third one, first two positions are zeros. Now add all of them. 1, 2 plus 0, 2. Again 2 plus 0, 2. Now I am taking the one of the first coefficient. 1 2s are 2. I am writing here. 3 2s are 6. But here we should not take this. We should not take the value here because it is already occupied with 0. So we no need to multiply here. When you multiply, you have to write from here onwards. Okay, na? Yeah, minus 3 plus 2 is minus 1. Now 1 into minus 1 is minus 1. Now here 3 into 2, 6. 6 you should write here. Now take the positive terms. 5 plus 6, 11. 11 minus 1 is 10. Again with 1, 1 tens are 10. Now with 3 I have just multiplied with 2 only, but still minus 1 will be remaining. 3 into minus 1 is minus 3. Now here there are two negative numbers, one positive number. Let me add the two negative numbers. Minus 3 is minus 6. Minus 6 plus 10 becomes 4. Okay? Right. Now again 1 4s are 4. Now 3 into 10. 3 tens are 30. Okay, na? So this will be 41. Because all our positive numbers are just adding, you will get the answer is 41. Now again 1 into 41, 41, but we are not taking here in the place of this. We are getting already 0. So that's why I can leave like that. So remaining 3 table, 3 4s. 3 4s are 12. Minus 9 plus 12. Different symbol, subtraction. 12 minus 9 is 3. So we are dividing with quadratic polynomial. That's why last two terms are remainders. If it is divided by linear polynomial, only one term will be remainder. But here two terms will be remainders. So that means constant term is 3. Constant term after x term. So this is the remainder. 41x plus 3 will be the remainder. And the remaining will be quotient. What is the quotient? 1, 2, 3, 4. 4 terms means cubic polynomial. Yeah, 2x cube minus x square plus 10x plus 4 will be the quotient. Okay, na? Check here. 2x cube minus x square plus 10x plus 4. third option, quotient and remainder is given here side by side like this. So our required answer is 3. This one. Okay, na? So first, biquadratic polynomial divided by linear polynomial. We did the division by using the synthetic division. And second one, 50-degree polynomial with quadratic polynomial. Remainder I got linear polynomial. Okay, na? Right. Let us go to third question. The equation whose roots are 1, -1, 3. Already roots are given 3 roots. It means it could be cubic polynomial. So let us take alpha value is 1, beta value is -1 and gamma value is 3. So alpha, beta, gamma are 3 roots of the given polynomial. We need to find that polynomial. We have learned in our previous class that is nothing but x minus alpha into x minus beta into x minus gamma will be the required polynomial, right? Let us substitute. X minus alpha value is 1, x minus beta value -1, so this will be minus of minus plus 1, and x minus 3. I am going to multiply first two. They are in the form of a minus b into a plus b. A minus b into a plus b is nothing but a square minus b square, right? So this is x square minus 1 square into x minus 3. Okay. Now x square minus 1 square value 1 itself. Now this is binomial into binomial. We need to multiply x square into entire second binomial x minus 3. And -1 into entire second binomial is x minus 3. Now x square into x, x cube minus 3x square minus x plus 3. There are no like terms. This is our required answer. X cube minus 3x square minus x plus 3 is last option. Okay, now? Right. Next, the equation whose roots are 1, 2 plus or minus 3i. That means 1, 2 plus 3i, 2 minus 3i. Because here plus or minus is given, so plus term 1, minus term with 1 root. Okay, 3 roots. 3 roots means obviously cubic polynomial. Same like previous one, x minus alpha, x minus beta, x minus gamma. So same condition I am applying here, x minus alpha into x minus beta into x minus gamma. That equals to x minus alpha value 1, x minus beta value is 2 plus 3i, and third one x minus 2 minus 3i. Okay, no? Right. So x minus 1 as it is. Now here with minus, I am removing this bracket with multiply with this minus symbol. So it will be x minus 2 minus 3i, and this one also x minus 2 plus 3i. Am I right? Because minus into minus become plus. Now this x minus 1 as it is. Now observe here. Observe here, x minus 2, this entire term is considered as a, 3i as b. So a minus b into a plus b. A minus b into a plus b formula, a square minus b square. Am I right? Yeah, same formula applying here, a square. That means x minus 2 whole square minus b square, 3i whole square. Okay? Right. So x minus 1 into, this is in the form of a minus b whole square again. So a square minus 2ab plus b square, here minus 3i whole square, 3 square 9, I square value minus 1. I square value is minus 1. You will get this concept in complex numbers, okay? So we'll discuss that detailedly about it, I square value, how it becomes minus 1. So just until then you remember the value. So 9 into minus 1 plus 9. Now simplify this, x square minus 4x plus 13, this one. So x minus 1 into x square minus 4x plus 13. So I am just multiplying directly with this binomial to trinomial. So x square into x cube minus 4x square plus 13x. That means these three terms I am just multiplying with x. Now I have to multiply with minus 1. So minus x square plus 4x minus 13. Now identify the like terms among this. So x cube only single term, it is not a like term here. And minus 4x square minus x square minus 5x square. 13x plus 4x is 17x and minus 13. Okay. So this is our required answer. Let us identify this. X cube minus 5x square plus 17x minus 3 is nothing but last. This is our required answer. Okay, na? Let us go to the next problem. Yeah, the equation of lowest degree with rational coefficients. Lowest degree with rational coefficients. When you have the rational coefficients, the roots can be in complex surds. Am I right? So here one of the root is given, that is root 3 plus root 2i. So their complex source becomes root 3 minus root 2i or minus root 3 plus root 2i minus root 3 minus root 2i. 4 will come. 4 complex roots will come or complex surds will come, whatever. So this is one of the root. I am taking this pair here and this pair here. So that means total 4 roots. 4 roots are nothing but there is a formation of biquadratic polynomial. Okay, no? Which polynomial? Biquadratic polynomial. So let us find the equation by using these two, and by using these two roots, then let us multiply both of them together. Then biquadratic polynomial will forms. So from this, let us take this alpha and beta. According to our condition, we need to take x minus alpha into x minus beta. Okay, na? Substitute here. There is nothing but x minus alpha value root 3 plus root 2i, first one, and second one x minus root 3 minus root 2i. Okay, let us simplify this without the minus symbol, without this bracket here. I am writing this x minus root 3 minus root 2i and x minus root 3 plus root 2i. Same like previous problem, first two terms here in the first bracket, first two terms here, first two terms are same and second terms are same, but only the symbol changes between them. So it is in the form of a minus b into a plus b, nothing but a square minus b square, one of the algebraic identity. Let us apply here. Okay, here that is a square x minus root 3 whole square minus b square means root 2i whole square. So apply a minus b whole square formula here. A square means x square minus 2ab, that means 2 root 3 into x plus b square. Root 3 whole square means 3. So x square minus 2 root 3 plus 3 minus, still minus symbol also is there here. Yeah. Minus root 2i whole square. Root 2 square is 2, I square value minus 1. So previously one negative symbol is there, so it becomes plus 2. So 3 plus 2, 5 overall. That equals to x square minus 2 root 3x plus 5. Okay. Now let us find from here. So I am going to write directly somewhat. Yeah. Now this one, so x minus alpha, that means I am directly applying the minus symbol for first one. So minus root 3 becomes plus root 3 and plus root 2i becomes minus root 2i. So this is in the form of x minus alpha. Now x minus beta, x minus again plus root 3 plus root 2i. Same like here previous one, a plus b into a minus b formula, a square minus b square. That means x plus root 3 whole square minus root 2a whole square. Same will come, right? But here minus is given, here plus is given. So last answer will be symbol changes. That means x square plus 2 root 3 x plus 5. So total overall 4 factors. By using the first 2 factors, I found out the quadratic polynomial. By using last 2, again I found the quadratic polynomial. Let us find the final answer. Quadratic into quadratic by quadratic. Now here x square plus 5, I am writing here this one. I am writing as x square plus 5 minus 2 root 3x. Can I write like this? I am just interchanging the position of second and third term. Now let us find here, that is x square plus 5 plus 2 root 3x. Now again a plus b into a minus b, here a square minus b square. A square minus 2 root 3x whole square. A square minus b square. So apply here a plus b whole square formula, a square plus 2ab plus b square minus 4, 4, 3 is 12x square. Okay? So that is x power 4 minus 2x square plus 25. X power 4 minus 2x square plus 25 will be the first option. Okay now? Yeah. Now let us go to the next problem. If alpha, beta, gamma are the roots of the polynomial x cube plus x square plus x plus 1 equals to 0. This is a cubic polynomial, highest degree is 3 and contains the 4 terms. So all terms are presenting here. Okay. Next, we need to find alpha square plus beta square plus gamma. So before that, let us discuss one concept here. Let us take sum of, for example, while you are observing that nth degree polynomial is in the form of a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus and so on plus an. Here alpha 1, alpha 2, alpha 3 and so on, alpha n are roots of this nth degree polynomial. Fourth degree polynomial we have almost at most 4 roots, nth degree polynomial at most n roots. Am I right? So the n roots will be alpha 1, alpha 2 like this. Now here conditions you should learn, that is sigma alpha 1 means alpha 1 plus alpha 2 plus alpha 3 and so on up to alpha n. We have to add. This is considering as S1. This is considering as S1. Okay? That equals to S1. So this S1 value having a formula, that is A naught into S1 plus 1 into A1 equals to 0. This is the condition for sigma alpha 1. That means sum of all its roots. Next, second one, sigma alpha 1 square. That means alpha 1 square plus alpha 2 square plus alpha 3 square plus and so on plus alpha n square. Nothing but square, sum of the squares of the roots. Sum of the squares of the roots. For this we are considering is S2. Here we should learn the condition here. A naught S2 plus 1 into, 1 into A1 S1 plus 2 into A2 equals to 0. So S1, S2 only will be there. That means to find S2 value, again we need to find S1 also. Same like alpha 1 cube, that we have to consider as S3. So how to write here? First A naught with S3. Next 1 into A1 with S2 plus 2 into A2 with S1 plus 3 into A3 equal to 0. Now while you are observing here, we need to find alpha square plus beta square plus gamma square, nothing but sigma alpha 1 square, that formula sheet. Okay, because cubic polynomial having that sum of the squares of the roots we have to find. Now before that, let us find S1 value. Before that, I am writing that given polynomial f of x equals to x cube plus x square plus x plus 1 equals to 0. Okay, no? Right. Now S1 value. S1 is what? S1 equals to A naught S1 plus A1 into 1 into A1 equals to 0. This is the condition. Okay, no? A1, A naught, A1 is nothing but A naught is the highest power quotient. Next one A1, A2 like this. So here A naught means here 1. That means 1 into S1 plus 1 into A1 value is also 1. That equals to 0. 1 into S1 means S1. Here 1 into 1, 1 plus 1 transpose that side minus 1. So we got S1 value minus 1. Now S2 value. What is the formula for S2? A naught S2 plus 1 into A1 S1 plus 2 into A2 equals to 0. Substitute here, A naught value is 1, S2 we need to find, plus 1 into A1 value is also 1, S1 value is minus 1, plus 2 into A2 value also 1. Okay, now? So let us simplify this. 1 into S2 is S2. Here 1 ones are 1. 1 into minus 1 becomes minus 1. Plus 2 ones are 2. Now here itself we can cancel 2 minus 1 is plus 1. That means S2 plus 1 equals 0. S2 equals to minus 1. Therefore the answer is minus 1. Please note it, children. We'll go to the next problem, okay? Yeah, the roots of the polynomial here. We need to find the roots of the polynomial x cube minus 3x squared plus 2x equals to 0. Okay, na? So, while you are observing here, I am writing the polynomial here f of x equals to x cube minus 3x squared plus 2x equals to 0. Cubic polynomial should have 4 terms. That means one term is missing. There is no constant term. There is no constant term. But here, previous class we have discussed that for finding the roots for this, we must have the constant term. Then we are taking the constant term and writing all its factors. One by one we are substituting in the given formula. One factor we will find first. From that remaining factors we can find. Okay? But here not their constant term. But in this situation we can apply the statements like sum of all its coefficients are 0. Then 1 will be the factor or 1 will be the root. Sorry, not factor. 1 will be the root or solution of the given polynomial. And second statement is sum of even powers with constant. Sum of coefficients of even powers and constant is equals to sum of coefficients of odd powers. Then x plus 1 will be a factor, minus 1 will be the root. Okay, no? Now let me find the coefficients here. X cube coefficient, odd coefficients I am writing here. Odd coefficient means x cube term, x term. Here 1 plus 2 that equals to 3. Now even coefficients with constant term. There is no constant term. We can directly check the even coefficient is minus 3. Okay, na? So plus 3 minus 3. When you add both of them, becomes 0. Right? Yeah. That means x minus 1 will be the, x plus 1 will be the factor, minus 1 will be the chances of getting root or solution. Now let me find f of minus 1 that equals to minus 1 whole cube minus 3 into minus 1 whole square plus 2 into minus 1 equals to 0. Minus 1 whole cube value minus 1. Here minus 3 into 1 square is 1. Minus 2 equals 0. All are negative terms, therefore x plus 1 is not a factor. Okay, na? Now I am only substituting here 0. So this is not work out. We don't get any possibilities of getting the factor of 1 and minus 1. So it is failure. So let us take this given polynomial here, x cube. Excuse me. Yeah. x cube minus 3x square plus 2x equal to 0. But here I could sense that all are having the x is a common factor. Now let me take x is a common factor. This can be x square minus 3x plus 2. That means from every term I have taken x as a common term. Now it will be quadratic polynomial. I can find easily the factors by using splitting the middle term. Constant term is 2. 2 I can write 2 ones are 2 because factors 2 in 1 and itself because it is a prime number. Now but I should get minus here between, so both are taking minus 1 here. So simply this one I can write x minus 2 into x minus 1. X minus 2 into x minus 1. Okay. So this x I can write x minus 0, x minus 2, x minus 1 equal to 0. Therefore 0, 1, 2 are roots of the given polynomial. If x minus 0 is a factor, 0 will be the root. X minus 2 is a factor, 2 is a root. X minus 1 is a factor, 1 is a root from factor theorem. Second option. Okay, no? Yeah. So let us go to the 8th question. So if 2 is the root of this cubic polynomial or cubic equation, then the roots are remaining roots we need to find. Okay, na? Right. So x cube, I am taking the given polynomial here, x cube plus 3x square minus 4x plus k equal to 0. That means before we need to find k value because there are two unknowns, no? So let us find k value by substituting 2 here. So f of 2 equals to 2 cube plus 3 into 2 square minus 4 into 2 plus k equal to 0. Because whenever it is given that 2 is a root, the answer when you substitute the 2 value in the given polynomial, it will become 0. So that's why I have taken 0 here. 2 cube value 8 plus 2 square 4, 4 3 is 12 minus 8 plus k equals to 0. Minus 8 plus 8 cancel, k value minus 12. K value minus 12. So now the fresh polynomial is x cube plus 3x square minus 4x minus 12 equal to 0. Now we need to find the remaining roots. Okay, now. So how to find the remaining roots? From this we know that x minus 2 is one of the factor. 2 is a root means x minus 2 will be the factor. We can do the synthetic division or directly division we can do it. And the quotient will be in the form of quadratic. Again we need to find the roots. Okay, now. Now in the place of that process I am using the synthetic division here. So taking 2, here 0 because 2 is already root. 1 plus 0 is 1. 2 ones are 2. So 3 plus 2, 5. 2 5s, 10 here. So minus 4 plus 10 becomes 6. Here 12. Last one 0. So there are 3 terms remaining, nothing but quadratic polynomial, that is x square plus 5x plus 6. So 6 factors. 2 3s are 6. 2 plus 3, 5. That means we can write x plus 2 into x plus 3. Therefore minus 2 and 3 will be the root. There are already minus 2. Okay, not given here. Minus 2, 3 will be there. Minus 2 plus 2 minus 3. Fourth option. Okay now? Yeah, that's good. Let us go to the next question. Equation of roots. 3 roots are given. How to do it? X minus alpha into x minus beta into x minus gamma. So let us simplify this as early as possible. So that means x plus 2, x minus 1, x minus 3. I am multiplying first 2 here. X into x, x square minus x plus 2x minus 2 into x minus 3. Okay. Now simply I am multiplying here these two. Minus x plus 2x means plus x. So x square plus x minus 2 will be remains. Now with multiply with x minus 3. So with x cube x square minus 2x minus 3x square minus 3x plus 6. So I multiply these 3 terms with x as well as minus 3. Now identify the like terms here. X cube x square minus 3x square becomes minus 2x square, and minus 2x minus 3x becomes minus 5x, only constant term single. X cube minus 2x square minus 5x plus 6. Okay, now? Quotient and remainder. Quotient and remainder means synthetic division we should use. Let us do it here. Coefficients. So 3 minus 1, 2 minus 2 minus 4. 1, 2, 3, 4, 5 terms means it will be biquadratic. Yes, biquadratic only. X plus 2 factor means minus 2 will be the root. Here 0, 3, minus 6, minus 7, plus 14, 16. Next minus 32, minus 34. Am I right? Yeah, minus 6, minus 7, yeah, plus 14, 16, minus 32, 34. So minus into minus plus becomes 48. So 68, sorry. Minus into, so this minus 2 into minus 34 is plus 68. Subtract 64 will be, so last one is remainder. And the remaining, that means 3x cube minus 7x square plus 16x minus 34 will be quotient. Okay, na? Yeah, first one. Okay, now? So that's it for today, children. Thank you, one and all. Have a nice day. Bye-bye.